Okay, good job. I'm way happy you guys remembered everything. So it says, right, a general formula, just a reminder, once again, a lot of you are not simplifying, so watch. You knew that the general formula to find any term in the sequence, if it's arithmetic, is a sub 1 plus n minus 1 times by the common difference. So a sub 1 was 3 plus n minus 1. What's the common difference? You're adding 3 each time, okay? So a lot of you left it like that, which is fine when calculating this. However, when we start adding these, which is called a sum, when we start putting plus signs in between these, you've got to have this in like simplified form. So we would take the 3, we'd multiply it in. So that'd be a sub n is equal to 3 plus 3n minus 3. So wouldn't that be a sub n is equal to 3n? And then we would plug in a sub 63. So that would be 3 times 63, which is, thank you. So the 63rd term, did you get 189? Okay, cool. Just making sure. The 63rd term was 189. Okay, cool. All right, you guys are awesome. Okay, so now let's practice this. We didn't do this in this hour, and I want to show you how it works because we did it in all the other hours. So if I said to you, find what n is, what I mean by that is here's a sub 1, here's a sub 2, here's a sub 3, and then dot, 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 here's some a sub n. We don't know what term this is. You see what I'm saying? It's some n term. So if we find that n is 20, don't we know that that's the 20th term? A sub 20 would mean 20th term. So this is how we would do it. We'd say, well, what formula do we know for arithmetic sequences? A sub n is equal to a sub 1 plus n minus 1 times by the common difference. And now what you would do is plug in everything you know. This is really important. This is always so hard for people on the next lesson, and hopefully connecting it today is going to make a lot more sense. So a sub n, we know what a sub n is. A sub n is 62. You see how a sub n is that term we're talking. So 62 is equal to, our a sub 1 is 2 plus, but we don't know what n is. We knew a sub n, we didn't know what n was, but we do know our common difference is, it looks like 2, true? Now what we would do is look at the equation. You see how there's only one unknown, n. So now we would just use algebra to solve for n. So we would subtract 2. So we would get 60 is equal to n minus 1 times by 2. There's many ways algebraically to continue. Let's just get rid of this 2. Any suggestions? Divide by 2. Okay, so that would be 30 is equal to n minus 1. So then we would add 1. So n equals 31. Does everybody see how nice this is? Now we know this is a sub 31. This is the 31st term. Does that make sense, everybody? Yes. Say that one more time. Yes, but this one was 2, jumping in 2, so it just worked out kind of that way. So it won't always come out as nicely, if that makes sense. So if you can see it, that's fine. But a lot of times you won't be able to, because I started out with an easy one. You know what I mean? Okay, cool. Good question. Okay, let's start today's lesson. Last time you saw it was actually quite easy as long as you knew what you were doing. Same thing today. So last time we were dealing with arithmetic sequences, which meant there was a common difference from one term to the next, or meaning we were adding the same thing each time to get from one term to the next. So today is similar to an arithmetic sequence, but geometric sequences have a pattern where we're multiplying by the same thing to get from one term to the next. We're not adding. So like I said, in an arithmetic sequence, between each term there is a common difference, where in geometric there is what's called a common ratio. So what common ratio is, just like we don't say, oh, we're adding 3 each time, we call that a common difference. We actually are going to go backwards and subtract. Just like right here, for example, well, this is, we're adding 2, right? But what we did was common difference. 8 minus 6 is 2. 6 minus 4 is 2. 4 minus 2 is 2. A geometric one will have a common ratio. We'll go backwards, so we got to divide. So we do 27 divided by 9, which is 3. 9 divided by 3. 3 divided by 1. 3. So do you see how we are multiplying by 3 each time to get from one term to the next? But once again, we're going to use the word common ratio because ratio means division. That's going to be what you see in the formula is the R, the common ratio. Okay, so do problems 1 through 9 on the worksheet. Decide if it is geometric. If so, what's the common ratio? It's got to be the same thing each time. You do need to divide each term to see if it's always the same thing. It's got to be the same thing that they're multiplying by each time. So, last time we saw that with an arithmetic sequence, you can write a general formula that allows you to find any term in the sequence. That's what the bell quiz had to do. Well, there are also, obviously, general formulas for geometric sequences. Now, remember, there are what's called explicit formulas and recursive formulas. So an explicit formula is what's our favorite. That's why I have a smiley face. It's the most usable because you don't really need to know as much. All you have to know to find any term in the sequence is take a sub 1. Where did we start? Times by the common ratio. So times by r raised to the n minus 1, where n is the nth term you're talking. So you just need r and a sub 1, and you can find any term in the sequence. Now the recursive formula, the recursive definition, I put a like not frowny face because it's not bad, but it's not good. It's easy to write, that's why it's not bad, but it's not usable because it says any term in the sequence is the previous term times by some value. Makes sense, right? You take the previous value times it by 2. Easy to write because it's just what you see happening, but then you have to know the previous term, which you won't know unless it's right there in the beginning of the sequence. So write both of those down, because a lot of people ask, well, then why do we need this? Because they're going to ask you to write a recursive formula. Distracting, and it's in my video, and it's ruining it. So it says, write an explicit formula and write a recursive formula for the geometric sequence. So everybody, let's look at this. So our explicit formula was this one. A sub n is equal to a sub 1 times by r raised to the n minus 1. The recursive was a sub n is equal to a sub n minus 1, the previous term, and then times by some ratio. Okay, let's figure out our ratio. 32 divided by negative 16. Negative 2. Negative 16 divided by 8. And negative 2 and negative 2. I want you to notice something. This is really important to notice. So do you see how we start with a sub 1 of 2? And it's positive. Then we times by negative 2. A positive times a negative is a negative. A positive times a negative is a negative. Now think about it. The next time we times by negative 2, won't it be a negative times a negative, which is a positive? So if you have a negative in there, it's going to bounce back and forth between positive and negative. If your r is negative, that is. If your r is negative, it's going to bounce back and forth. Okay, cool. So here we go. Explicit formula. A sub n is equal to a sub 1 is, we're starting with 2, then we're going to times by negative 2. We've got to use parentheses because that's negative. So it's going to be negative 2 raised to the n minus 1. This is leaving it general because now we can plug in and find any term. If I say find the 10th term, you plug in 10, correct? If I say plug in the 100th term, you plug in 100. Okay, here's our recursive definition. You'd say a sub n is equal to the a sub n minus 1 never changes. You take the previous term, and then you times by negative 2. You take the previous term times by negative 2. The previous term times by negative 2. So then times by negative 2. Okay, awesome. Okay, so I think this one's on your, is this one on your worksheet? Similar? Okay. If I just watch them, that's okay. Just watch this one and I'm going to let you go for it. I'll give you some time. So you'd say, okay, here is this, find the 40th term. You'd say, here's a sub 1. My common ratio is positive 3. So I'd say a sub n is equal to a sub 1, 3, times by the common ratio of 3 as well, raised to the n minus 1. It says find the 40th term. That's a sub 40. So 3 times 3 raised to the 40 minus 1. The 40th term is 3 times 3 raised to the 39. So type it in. And then what would the 39th term be? It's going to be big. Because think about it. We're timesing by 3 each time. This is going to get pretty big here quick. So everybody, it's so big that your calculator can't write the number. It's a scientific number. So what you're seeing is this. 1.2, and then e to the 19. So what does that really mean? Yeah, so this means this. 1.2, good way to remember, times 10 to the 19th power. So that would be taking the decimal and moving it 19 places this way. We're not going to write it out. Let's just leave it in scientific form. Okay, cool. Do problems 10 through 18. With arithmetic, I showed you two ways, and sometimes one way is better than the other, and sometimes the other way is better. You've got to be able to really do both. So it says, find the missing term of the geometric sequence. Here's the first way to do it. So I would make note of it, find place in your notes, or on your paper up on the side. You've got to be able to do it both ways. So way number one, we're going to say, let's do it by solving for what we're timesing by each time. Like when we solve by seeing what we were adding by each time. So let's have a true statement. Everybody watch very carefully. So we know we got to keep track of how many times we're multiplying. Starting with 4, everybody. We're timesing by some amount, and it will get you there. True? Then we're timesing by, we'll take that amount and times by that same thing again, and we will equal 16. Does everybody see? So we have 4 times question mark equals 16, because it's the same thing. We're timesing by the same amount. So now look what we have. 4, then we have question mark squared equals 16. Now solve for question mark. Divide by 4. So we would have question mark squared equals 4. Now what would we do to solve for question mark? Square root. Now here's what we cannot forget. When solving and taking a square root, we can't forget a plus or minus. Square root, root cancels out with power. Question mark is either positive 2 or negative 2. One of the two. We're timesing by positive 2 or negative 2. We can't forget plus or minus. So don't be mistaken. That's not a plus. I mean, it is a plus sign, but it's a positive sign. So I'll just write positive 2. So now let's see. So you would have to actually write out 2 answers. So let's pretend we're timesing by question mark equals 2. 4 times 2 is 8, positive 8. Times 2 is 16. Let's pretend question mark is negative 2. 4 times negative 2 is negative 8. Look, times by negative 2 is 16. Do you see how either really works? So you would have it, we don't know. It could be 8, it could be negative 8. We really don't know. Right, because it'll be this, yeah, because we didn't take a square root, so there wasn't a plus or minus, yeah. Okay, let's do it with way number 2. So I'm going to start back from the beginning. We had 4, comma, we don't know, comma, 16. All right, let's solve directly for the missing value. We can only do this, though, if there's only one slot in between the two terms. This way is easy, but if you can only use it if there's only one box here. So isn't it true to say 16 divided by this value will be equal to this value divided by 4 in that order? Common ratio. So what's our true statement? We said 16 divided by x. 16 divided by x will be equal to x divided by 4. There's our true statement. So now we would just get to solve directly for x. So we would times up by 4, or technically times by 4 to both sides, times by x to both sides. So times by x. Do you see how the x's divide out? 4 times 16 is 64 is equal to, what's x times x? X squared. Now we'll solve for x. What would we do? Square root both sides. So you said x is equal to either positive or negative 8. Yes. And that was solving directly for the missing value. Both ways are great. Not one is better than the other. Okay, so let's make sure we're good. Let's do number 21 together on the worksheet. So which way do you like better? Putting the x and solving directly for it? Hey, everybody has a different opinion, so I don't know. Let's just go with this one. So my true statement is 16 divided by x is equal to x divided by 9. So now we'd multiply up by 9, multiply up by x. That gets rid of our denominator. What's 9 times 16? 144 is equal to x squared. Therefore, x is equal to plus or minus 12, because we would square root both sides. So we don't know. It could be positive or negative 12. Now that is what's called finding a geometric mean, a geometric average. We're finding the average, the middle thing between those, but it's geometric. Remember how there was arithmetic mean? There's also what's called a geometric mean. So this is how you would set up a geometric mean. Now on your end level test, literally, I've seen them say, find the geometric mean, find the geometric mean, they'll write it out, I'm just hurrying, of 9 and 16. And so you'd have to know how to set that up. And that's how we just did it. We would say, okay, 16 over x will be equal to x over 9. You see what I'm saying, everybody? That's the geometric mean, the average. Okay, cool. So let's see if you could do it with this one. You got to be able to do harder ones. I'm not going to just put all the easy ones on the test. So see if you could extend your knowledge and find all the missing pieces. Ready, set, go. Work together. So I hear a lot of you talking better, which is great. So you would say, right here we would do a true statement. So we'd start with 1 times something equals that, times something again equals that, times something again equals that, times one more something equals 2401. So now we have 1 question mark to the 4th equals 2401. So to solve, we would divide by 1. So we would have question mark to the 4th equals 2401. Then you would 4th root both sides. We just took an even root. Even roots need plus or minuses. So you get question mark is equal to plus or minus 7. So then you would go through, you've got to list out 2 answers for this. If you times by 7, you get, let's do positive 7. So if you times by 7, you'd get 7. Times by 7, you'd get, times by 7, you'd get 343. Okay, now let's pretend question mark is negative 7. Some of these are going to come out negative. 1 times negative 7. So we'd write that below it. Times negative 7. Positive 49 still. Times negative 7. Negative 343. That's how we would write it out for the test. It would be either of those. Okay, let's do one more, because this one does not need a plus or minus. Just a reminder of why. So we'd say 1 times something equals that, times something again, equals that, times something again, equals 125. So then we have 1 question mark cubed equals 125, divide by 1. So then we have question mark cubed equals 125, and then wouldn't we cube root both sides? Well, odd roots do not get plus or minuses. They're either positive or negative, depending on if it's positive or negative underneath. We can take the cube root of negative 125, that would be negative 5, but it's positive 125, which is 5. We are only timesing by positive 5 for sure. 1 times 5 is 5, times 5 is 25, times 5 is 125. Does that make sense? Odd roots do not get plus or minuses. Even roots do. It's that simple. Okay. All right, let's go to the problem 38. It says, write an explicit formula for each sequence, then generate the first 5 terms. So notice it gives you everything you need, because our explicit formula for geometric was this, a sub 1 times by r raised to the n minus 1. Let's just always use parentheses from here on out so we don't end up making errors on the test. Because if our r is negative and you don't have it in parentheses, it's not going to raise it, even the negative to all this, and you would need it to. So it says write out the first 5 terms, or write out the general formula. So a sub 1 is 3. And then we're timesing by negative 2 raised to the n minus 1. Does everybody see how that's general? There's our explicit formula. If I said write a recursive formula, what do you just go like this? A sub n is equal to a sub n minus 1, the previous term times by negative 2. Everyone? That's a recursive formula. And then you would also kind of say, they would say on a test, they would say starting with a sub 1 is 3. Just because we have to know where to start. Okay, anyways, just making sure. Okay, generate the first 5 terms. So we know it's 3, then times by negative 2 is negative 6. Times by negative 2 is 12. Times by negative 2. Do you guys see what I'm doing? Negative 24 times by 2 is 48. Let's see, how many terms is that? 1, 2, 3, 4, 5. We've listed out the first 5 terms. Yeah, I didn't want to have to plug it in because they're the first 5 terms, so I'm just going to multiply straight through. So we're just multiplying by negative 2 each term. Yeah. Or you could go through the long process of plugging in a 1, 2, 3, 4, 5. And yeah, that would work too. Okay, go to 48. I'm going to let you go back to that, but this is my last example of the day, almost. 48. Give me 5 more minutes of your time. The rest of the time will be yours. So here we go. It says you enlarge the dimensions of a picture up to 150% several times. So if you start with a picture and you're enlarging it by 100, but then also 50%, it says after the first increase, the picture is 1 inch wide. So just be careful here. Write an explicit formula to model the width after each increase. We got to be careful. This one's almost, it kind of seems like it's a trick question. We could make it harder than it needs to be, but just keep this in mind. So really it says after the first increase. So didn't we start somewhere and then we times by 150%, true? Our R, written as a decimal, we write 150%, we would write as a number. How do we write that as a number? So we're timesing by 1.50. Just for everybody to see, 100 and then 50 more percent, right? So we're timesing by that, and then we get 1 inch. Does everybody see? So do you see how we need to find where we started? Because that was after the first one. So you did what? You're right. So look, do you see how we could solve for the first one? Because so you just do algebra, divide by 1.5, divide by 1.5. What do you get? 2/3, you said? Okay, cool. So it was 2/3 an inch to start with. Does everybody see? So we'd say our explicit formula is a sub n. So you just have to watch out for trick things like this. The word after 1 increase, we start here. People often start at 1, but that's not necessarily true. So our a sub n is equal to a sub 1, which you said was 2/3 inch, 2/3. And then we're timesing by 1.5. And then raised to the n minus 1. Is that true? Now that makes sense because it says after the first increase. If you plug in 1, wait a minute. Yeah, if we plug in 1, that'll work. But do you see how that kind of confuses people? I would have to, so what would a sub 1 be? 2/3. So it says after the first increase, don't let the word first mess you up. That's a sub 2. That'd be our second term. So it says, how wide is the photo after the second increase? Don't be mistaken. Don't plug in a 2 on accident here. What would that be? What term would that be? The third term. Does everybody see what I'm saying? Okay, so we would say a sub 3. That'd be the third time. The third term, not the third time, the third term, because we started here. So then 1.5 raised to the 3 minus 1, which is 2. So do you see how that makes sense? Because now what's the second time? Okay. How wide is the photo? Actually, you're going to want to put this in parentheses as well, just to be sure. It might be okay. Yeah, it just depends on people's calculators. I just want to be safe. Cool. So it's 1.5 inches. How wide is the photo after the third increase? This would be our fourth term. Okay. Inches. How wide is the photo after the 12th increase? Now, what do we need to be plugging in 13? So we would say a sub 13 is equal to a sub 1, 2/3 times 1.50 raised to the 13 minus 1, which is why I'm just going to put 12. What did you guys get? Yep, 86.5. Yeah, somewhere. Hey, everybody listen to my last example, 49. Actually, I think you can do it by yourself. Let's just make sure you're good to go. So it says missing pieces. So this is exactly what we just did a second ago, right? Do you even need me to go over it? Okay, sounds good. And the rest of the time is yours. Let's see if you can get it all done before the end of class. If not, you can take it as homework, that's fine.